Welcome to reInvent. I think this might be one of the first sessions for many of you, so really honored to be the one to welcome you to this kind of fun, crazy week ahead. My name is Steph Rowan. This is Diego Del Molen. We are on in the AWS Partner Organization, and we focus on helping our partners build offerings that support resilience for customer workloads. So for the next hour, we're going to talk to you a bit about resilience in AWS, how we define resilience, how we talk about resilience to customers and with our partners. We're going to talk about what we see in the market, what we see when we're working with our customers, and how we're helping partners to address these customer challenges. And then Diego's going to dive into the technical principles, best practices around resilience, and then we'll wrap it up with programs and tools that AWS offers to help support our partners in addressing the customer needs and working together on sales opportunities. So with that, let's dive in. How many of you are here for the first time at reInvent? Yeah, me too. Me too, so it's exciting. I'm pretty impressed with how things are so organized so far. I've never been at anything at this scale, so it's been a pretty exciting experience already. You guys may have noticed that resilience has become increasingly prominent at reInvent over the last 3 years. So be it in keynotes, breakout sessions, even in the media, we're just talking a lot about resilience. Everyone's talking a lot about resilience. In fact, this year, there are 101 sessions around resilience at reInvent. So this is just one. So I guess you have 100 to go after this one. But there's some that are focused on direct to customer, technical partner, et cetera. So this is just a sampling of the sessions that I'm particularly excited about this year. You can explore in the app by searching resilience to find the other ones that kind of suit the topics of interest for you. We have a couple of resilience booths at the expo, one that's about resilience services and one that is about partners in particular. We're in the Cloud Foundations area of the expo, and it's booth 314. We'd love to see you come by, talk to us there. We also have we're participating in Builder cards over at the Mandalay. So if you're interested in gamified learning, there's some really cool things going on over there, and there's a collectible resilience card as well. We also have Ruba's keynote that happens on Wednesday at 3:30. We encourage you all to go attend that as well. So first, I just want to address what AWS means by resilience. So all up, dictionary definition, resilience is the ability to recover from or adjust easily to misfortune or change. Now, we align that with how AWS defines IT resilience, and that's the ability of a workload to recover from infrastructure or service disruptions. It's about meeting demand and mitigating disruptions, which may result from misconfigurations or transient issues. Now, this is our formal definition. I kind of view the digestible version as resilience is about minimizing the duration and impact of downtime, and we do this through best practices for design, operations, and recovery. So it's not about things not failing, it's about making sure that if they do fail, they recover quickly and gracefully. Now, for customer workloads on AWS, it is a shared responsibility, very similar to security. This is the resilience shared responsibility model. This is where AWS is responsible for the resilience of the cloud. This is services, our global infrastructure, our availability zones. And then customers, or their partners, are responsible for the resilience in the cloud. So this is about workload architecture, operational resilience, observability, many others. I think what's important to note in this model is that there's a lot of responsibility on the customer side. And we're finding there's a real need for partner support with customers when we're talking to them about resilience. In creating content for this session, Diego and I were just kind of reminiscing about our time in IT and how so often, despite our best efforts, things fail and varying degrees of impacts, but things fail in unexpected ways. And I'm going to pass it to Diego to share a little story.
All right, thanks, Steph. Well, I want to share the story. I was talking to Steph, trying to define when was the first time I realized downtime was something that will cause stress over customers or even over business. And I remember my first internship back in 2000s, way before the cloud, way before AWS. You can tell by the gray hair that goes a long time ago. I was responsible for an ERP system for a wholesaler type of company. And that's very easy to assume that this ERP is the most important piece of software for 24/7 operations. And I tried to do my best to protect and monitor and make sure that this server would never, or the system would never crash. One day, I get early in the morning, and there were a couple of teams that were pretty upset with a situation that happened overnight because they were not able to activate support. And it was a printing system that crashed. You may think, well, printing system, not that important. In that type of operation, this printing system was responsible for printing the road transport authorizations. So that means for that company, over a period of 6 hours, about 1,000 trucks could not perform their expected duties of delivering goods and just just hit the road and do what they're supposed to do. I'm pretty sure everyone here also can connect to some sort of downtime story. Either if you've been upset because a provider or a system that you're using were in a downtime, or even if you were responsible for a system to be available, and in that case it was not available. I'm pretty sure everyone here has gone through some similar type of situation. But I think the most important part of this story that I want to share is what I learned very early was the impact of downtime. And to me, in that case, downtime turned out to be very expensive. Back to you, Steph.
Yeah, and I think it's just an example of the impact in downtime and how often it is expensive in the unexpected ways. So depending on the industry and, of course, the size of company, downtime can cost thousands, if not hundreds of thousands of dollars per hour. And it's not just lost revenue, which is the obvious one, but I'm sure you all know and experience that it's brand reputation, it's productivity disruption, it's regulatory penalties, even employee turnover related to stress and morale after dealing with downtime. And these risks are continuing to rise as organizations increasingly adopt applications and marketplaces for everyday operations. And this is why the customers need help from partners. Customers are struggling. We're seeing customers struggling with dealing with their own customer expectations for websites and other applications to always be on, always be available. There's a trend toward remote teams and complex distributed systems and the more frequent releases, and these are all increase the risk of disruptions. And then there's new regulations being applied to industries and regions, for example, DORA in the EU, and this is just increasing the burden on the IT teams to remain compliant. And there are so many tools available to customers. AWS alone has a very, very large suite of services that contribute to resilience. So navigating all of the services in the market and how they work together for the best outcomes is challenging for customers to maintain knowledge of. And I think most of you in this audience are probably already working with partners in the capacities where resilience fits. So we have our consulting partners. You're migrating and you're designing critical applications. You are creating operational playbooks. You're planning disaster recovery strategies. And then we have our managed services partners who are also operating the infrastructure and the applications. You're managing patches and updates, continual assessments of security and disaster recovery. You're supporting the overall relationship, and this is where we see resilience fitting into your natural operations as they are today. So with this in mind, Diego, our team, we've created a go-to-market practice guide for partners. And it covers it covers 5 stages that we think of building resilience practice. And it includes building business commitments, so aligning your internal teams to incorporating and focusing on resilience, building that center of excellence, maintaining knowledge. Technical readiness, so all of the tools that you need to train your teams from a technical point of view, a sales point of view, marketing point of view on what services are available and how resilience applies to customers. Building the offerings, we have a lot of tools, packages that can support your building offerings around resilience specifically. And then go to market, so defining sales and marketing, we have turnkey messaging and different tools in that capacity for you to use. And then launch, how do we work together once you launch? How do we work together to drive opportunities and support our customers in this space? So with that, I'm going to turn it over to Diego, who's going to dive into the more deeply technical portions of resilience. Thank you.
Oh, thanks, Steph. All right. With that in mind, AWS developed some mechanisms, processes, and frameworks that are focused primarily in providing guidance to customers and partners on how to build resilient systems, or how to increase resilience of an existing system. From a technical perspective, I start implementing a resilience practice. I'd like to start with this very simple model. The first step, we need partners who help customers to implement foundations of resilience with these customers. By foundation, it means making a proper assessment, analyzing the risk of an application being down and how that influences the overall operations of this customer. Utilize DevOps framework or DevOps practice as guardrails to reduce human errors or some other techniques I'm going to cover. Observability, just observe the environment in a certain way that you can be alerted and you can understand the application behavior to see if it's working as expected. Once you put the foundationals of resilience in place, we need partners to help on designing resilient applications. And by resilient applications, by designing resilient applications, I mean the high availability spectrum of an application. If a container fails or an EC2 machine fails, you restart that, the system or the application continues to operate. That's not a big deal. That's pretty transparent to the customer. On the other hand, we also need to design for recoverability of this environment. In case of a catastrophic situation, data corruption, ransomware, somebody in a bad mood deleted a database on a Friday afternoon. How to recover this environment? There's a slightly different aspect of being highly available versus being disaster recoverable. And finally, operations. So operations also plays a big portion of the overall resilience spectrum because your operation teams, or either if you're an MSP provider or if you're training your customers to operate this environment, it's about the time it takes for them to detect the incident, the time for them to react to the incident and restore the normal operations. So those are the 4 pillars that I'm going to cover now with a little bit more detail. I will start with foundations. And in foundations, it's how you start engaging with customers and how to understand exactly their resilience needs. I'll cover assessment, observability, and DevOps as part of this fundamental concept for resilience. Let's start with assessment. Develop a good resilience assessment process. So instead of just asking your customers, is this HA? Is this DR true or false? Or HA true or false? Or jumping straight into conversations like multi-cloud or multi-region or multi-AZ. Just keep it simple, trying to understand what's the business impact for this customer, how much time they are willing to accept as part of the risk. Generally, that translates to RPOs and RTOs. Everybody here familiar with the concepts of RPOs and RTOs? Well, just in case to put everybody on the same page, RPO is a time measurement of how much risk the customer is accepting to lose data. So for example, if a backup is midnight and the system crashes noon, the customer is accepting the risk that it may lose 12 hours of data. RTO is the recovery time objectives. How long does it take for recovering this system? So if the customer wants the system to be recovered in 1 hour, in case of an incident, you have to plan accordingly for that. As part of a good assessment, you also have to consider what we call a risk assessment. So let me describe this scenario. E-commerce. Users browse product of catalog, they log in, put things in the shopping cart, and then they finally check out. So this is a user story in that system. Now I have to understand what are the risks associated in each one of the steps for this system. For example, what happens if my catalog is not available? What happens if EC2 that supports the catalog is down, or the database that supports the catalog is down? Or maybe if the catalog is under more load than it can actually support. So those are tabletop exercises to analyze the risk in what situations, how the system would theoretically behave. And it would be also recommended as part of your assessment phase. And of course, this is not a once and done type of exercise. As the systems are evolving and you're adding new functionality to the system, you also have to validate how the impact is added how the impact influences the overall system as new things are going on, or eventually new architectures. It's also impossible to determine how a system is going to be available without having proper observability and monitoring. So it's a really important concept as part of the resilience. And I would say start with business metrics. Of course, uptime, server uptime used to be one of the metrics we used for system availability. Try to bring that to the next step using, for example, business performance levels or service levels. The number of transactions that have been successfully executing the system versus the number of transactions that have been unsuccessful running the system. And that will give you also some error budget. That means if you have a 99% availability, that means 1% of the transactions would be acceptable to fail, and you can play around with those numbers. And again, resilience is all about the user perception of the system being on and available. So of course, you're monitoring the infrastructure and the application behavior, but it's also important to include user experience. After all, you have to simulate how the users are experiencing that system to see if that system is being demonstrating available to the customers. There are a few techniques using, for example, CloudWatch RUM or CloudWatch Canary, synthetic canary, to understand exactly how the system is behaving through the lenses of a user. And that helps to prevent something that we call gray failures. Gray failures is a situation where your monitoring says everything is fine, there's no errors, and you receive a call and there's some customers complaining that the system is not available. So even though from a monitoring perspective, it shows everything all right, there are actually some users with some errors. It's important to combine both, including the user experience, to make sure that you're monitoring all the perspectives. My final topic in the fundamentals is DevOps. Anybody here who is a DevOps certified validated competency partner? We have a few in the back end here. So from a DevOps perspective, I would assume many of you may think DevOps as a mechanism to increase agility. I would say think about DevOps as a mechanism also to put some guardrails when it comes to resilience. A few ways to utilize DevOps for that matter. Immutable deployments. Everything that you're changing in the system should be through code. That means you can repeat that behavior in a certain way, and you can start deploying a new version of that system in a separate environment, and start shifting over some of the users for that new environment. Something goes wrong, you still have the old environment that you know exactly how it's behaving, you shift the users back and you minimize the incident or you minimize the users that have been affected by any type of change. One of the ways of doing that is through canary deployments. So canary deployments is a process in DevOps that you start upgrading a node or a container or one of the servers in the cluster. And you start shifting traffic for that one first and monitor how that system behaves. And as it's behaving, you can tell, I can keep upgrading and putting more new versions of this software throughout my cluster, or maybe I need to pause and start rolling back and roll back to the previous version. I like to say that it's better to fail 5% of your users than actually failing 100% of your users. And finally, pipeline. Test everything as part of your pipeline. Every single unit testing, stress testing, every single error that you are testing that's not being pushed to production, that you were able to capture during the pipeline build process and test process, is an error that's not going to cause impact to the customers. There's some pretty good new mechanisms and way to build tests. For example, if you're experimenting right now Code Whisper, Amazon Code Whisper, it's pretty easy to write functional testings as part of using Code Whisper. So no excuse for not testing things as part of the pipeline. Well, I just completed the fundamentals, so like the DevOps, observability, and assessment. Now let me share some insights on how to design applications to be resilient. Anybody here migration partner that does modernization? Raise hands. Hopefully it's aligned with your principles in that. I would like to recommend you to invest into microservices and as part of a modernization practice. The reason for that is it's better to have, if a monolith fails, it's a full failure. If a microservice fails, it's a partial failure. So it's a partial failure is better than a full failure, at least from the user experience. When you're modernizing a system, it's also important that you apply some of this microservices approach, which is trying to decouple as much as you can from the application. That helps with a couple of things. You can scale, so that means the risk of one container dying and you have to replace with another one helps to keep the high availability part of this environment. But also, if you're decoupling and using some sort of processing queue for this application, that means you can retry later certain operations. For example, putting things in the shopping cart and checking out, if my payment gateway is having a bad day, I can retry in 2 minutes and 3 minutes. That's fully transparent to the user. But it's like not something that the user are going to realize, but it still will increase the availability levels for that. And as you're modernizing, there's another thing I would like to mention. Try to use region-based services. Amazon S3, DynamoDB. These services are already utilized throughout the full region that they were being processed and accessed. So that means in case of an availability zone failure, these systems are less likely to be impacted. Instead of you trying to manage something into a single availability zone and have to plan for that, let the managed services handle that type of configuration for you. This is one of my favorites. Customers and having discussion with customers, should I go multi-region, multi-AZ, or even sometimes multi-cloud? After doing a proper assessment, I would take the risk to say, there's a vast majority of customers, they can achieve their RPOs and RTOs and their resilience levels using a single region multi-AZ, and there are some techniques for that. I see there are generally 3 types of scenarios where we would use multi-region. The first one is data sovereignty. That data needs to sit in a specific region, not related to resilience, but is a multi-region strategy. The second one is also speed, like having customers in a global presence, having these systems present or closer to where the customers are, also increase the speed. That would be another difference for having multi-region services. Also not resilience, but third one, actually related to resilience. Customers who have a very, very sensitive type of downtime. We're talking about seconds of downtime cause $1 million type of impact. That would be the case of customers that can eventually request having multi-region as a strategy for their resilience level. Most important is, can you help these customers to achieve at least the resilience level that they're trying to achieve in a single region, multi-AZ, before you expand that to a multi-region? There are 2 links here that I would like to recommend. Architecture, the first one is architecture. Those are 2 AWS white papers. Architecture references for multi-AZ to increase resilience, and the second one is for multi-region discussions to equip you when customers are willing to have that type of conversation. And design applications for high availability is not only about AWS architecture. There are some components that goes, and something that you have to discuss with your customers in the software development lifecycle. Some things that goes in the software that make these applications to be more resilient. First one, if you're implementing like in the service client, you just try some retries. Retrying is a simple technique. If the database is busy at this second, you retry after 2 seconds, database may be not so much busy and can answer properly, fully transparent to the user. Don't keep retrying forever, because then the user is expecting the system to restore operations and eventually it's actually an incident. So it's just good that you retry a couple of times, fail elegantly. So just have that conversation with your software developers or the application owners that are having this to make sure that they implement these techniques. On the back end, try to rate the limits or implement some level of throttling. This is really good because if you design a high system, for example, for 1,000 transactions per second, and you have one customer taking those 1,000 transactions, for this customer is going to demonstrate as available. For the other customers, unavailable. So it's important to limit how much customers are accessing the system based out of pre-agreed formats. And finally, implement some circuit breakers. Circuit breakers is a mechanism where if one microservice is having some pressure, and that pressure is cascading down to the other services that are depending on these services, you can deactivate or open the circuit to fix and troubleshoot whatever is going on here, so you don't cause an impact in the other services. Whenever the service is reestablished, you close the circuit and then you can continue normal operations without impacting other microservices that are part of this application. Well, that's what we take for designing highly available applications. Now let's cover the disaster recovery aspect of it. So both availability and disaster recovery, they rely pretty much in similar or same best practice. We're talking about monitoring, deploying multiple locations, automatically failover, where high availability fails in the failing components, like an EC2 or a container that's failing. Disaster recovery focus on a full catastrophic type of situation that you have to recover this environment in a different location. And I'll just use a different region in that case. And it's a spectrum. There are different ways of doing that, and it all depends on the assessment that you've done with your customers to understand what type of disaster recovery is going to be important to help the customers to achieve what they're trying to achieve. First one, most common, I pretty much here understand that, backup restore. Very cost effective. The problem with backup restore is it may take a few hours to restore the environment, maybe tens of hours, depending on how complex the system is. And you may be losing some data as part of the RPO strategy. Like backup once a day or twice a day gives you like 12 hours of data loss that eventually could happen. In case customers, they need something more aggressive or something more optimized when it comes to RPO and RTO, Pilot Light would be the next option. In Pilot Light, you focus in replicating the data to a different region. I'll use different region just to keep it simple. Replicating the data to a different region. There are no servers running in the other side, just the data replication. When you need, it's very cost effective because you're not paying for the resources that are not running. When something happens, then you have to have the automation or scripts to just bring that environment up. RPO, you can achieve like second level type of RPO depending on the transaction, or depending on the replication system that you're using. But from restore point of system, it may take maybe a few hours to restore that environment. The third one is, I would say next towards the right, is warm standby. In this case, you're still focusing on replicating the systems to a different region, but you have some of the servers or the resources up and running expecting for an incident to happen. That's very optimal when it comes to just shifting a DNS record and start transferring users to the backup or to the restore region. So for customers that are looking for more aggressive RPOs and RTOs, that would be the recommended type of approach. The final principle I want to cover is about building operations for resilience. And start with the first one, operational readiness review. These are also some of the things that we do internally in AWS or in Amazon.com. Operational readiness review is a document in a process that helps to define how the system is going to be operating and how the system is going to be working when we put that in production. Who are the teams we are going to engage? What type of observability and alerting should we set up? Who are the teams that are going to be on call? What is the criticality for this application? What are the SLOs or service levels that we're trying to monitor? The next one is correction of errors. If you have customers that already implement some sort of incident management and they have some sort of root cause analysis, trying to discover what exactly happened when an incident happened. A correction of errors is an evolution of that because you're taking the lessons learned from an incident and transforming that into recommendations, either for architecture or for operations, to make sure that this incident is not happening again. It's really important because this should be like a blame-free type of exercise. It's not to point finger. It's actually the intention is to really bring up the availability levels for the applications. And finally, rehearse an outage. Like if everything is going on well, there are no incidents, you already improved this environment, why not breaking things on purpose to make sure that your teams are operated, your architecture and operation teams are equipped to know exactly what to do when a real incident happens. That can be achieved through fail injection experimentations or chaos engineering, game days. So what if I just unplug this cable? What could happen? How my system is going to behave? What if I publish a new version that hasn't been tested? How can I detect that? Or how can I detect if that causes any kind of incident in the system? I know it's a lot of information, but how do you actually can apply this to your customers? We just released the Resilience Lifecycle Framework. So it's a framework that captures the resilience learning and best practices. And if you align with everything that we just learned here, the first step is to set objectives. It's about the foundations. Like it's trying to understand exactly what RPOs and RTOs and SLAs these customers are looking for. Then you start designing for high availability or for disaster recovery to meet this customer's demand and interest. Then you start testing, like let me see if this application can meet the certain criteria that have been defined. If they meet, send to operations. Incident will happen and may happen. Let operations to handle the incident, lessons learned, generate new recommendations for improving operations or for improving architectures on this system. And this is a fresh new content that we just published maybe a couple of months ago. How can AWS help? So there's so many different services in AWS that has a vast majority of services in AWS that can help to define resilience from different perspectives, either through high availability, design, recovery, and operations. I would love to cover all of them, but I'm going to cover just two for this session. First one, for assessment. Everybody here familiar with AWS Resilience Hub? If you ever heard or used the Resilience Hub in the past. So AWS Resilience Hub is an AWS service where you define RPOs and RTOs, and you define the application. Resilience Hub will assess that application, and it will tell if you can meet or not the resilience levels that have been defined. In that case, I have a screenshot of a system that did not meet certain criteria. So in that case, Resilience Hub will give a recommendation, architecture design recommendation saying, change this on this application that will help you to meet that expected RPO and RTO. And not only that, Resilience Hub also provides recommendations about standard operation procedures using Amazon Systems Manager, some ways to automate your operations on how to recover quickly that environment, some alerting using CloudWatch on what exactly you should be monitoring and alerted so you can know before if an incident is happening, and also some fault injection service experimentations on how to use FIS, Amazon FIS, to try this application and make sure that it works as expected. The QR code link, this content is exclusive to partners. It's a guide that Steph, myself, and the team we build on how to help partners on building an assessment practice using FIS to determine if the systems if the customers is meeting their availability levels. And it's available in Partner Central. The last one is RDS, Amazon Elastic Disaster Recovery. Everybody here familiar with DRS or Elastic DRS? Oh. DRS is an AWS service that, as the name says, helps with disaster recovery. It focuses primarily in virtual machines, so that means if you install an agent in any compatible operating system, Linux or Windows, and doesn't matter if it's running on another cloud, Hyper-V, Windows, physical servers, that means you can protect the system and help the system to recover in the cloud, converting that as an EC2 server, and quickly restore that server as a disaster recovery. It also works from AWS to AWS in different regions. Same with the QR code. We developed a go-to-market plan for partners that want to build systems we want to build a practice around building a disaster recovery utilizing DRS for partners, for customers. Well, that's all that I have from the technical perspective. I'm handing back to Steph.
Thank you. Thank you. So we talked about the customer needs that are driving the need for resilience. And these are just some benefits for partners who are thinking about incorporating resilience into your offerings. We look at it as increasing customer satisfaction. And I think this is really about meeting their expectations. When customers are working with a partner, they're expecting that their applications and workloads are being built with resilience in mind. They're being built to withstand disruptions, to recover quickly. So I think right there, just meeting customer expectations by building resilience and talking about resilience with your customers, letting them know that you are addressing this with intention. And on the note of intention, I think that also differentiates your offerings in the market. Knowing that you are looking at resilience of critical applications, you have experience managing resilience of critical applications. These are market differentiators that we know customers are looking for. And then just increase of revenue opportunity. I mean, we know that there are RFPs out there that say that you must have XYZ experience in critical application management. So there's opportunity to drive revenue opportunities by meeting RFP requirements, as well as just increasing scope of consultative or managed services offerings. And we want you to drop by the booth, talk to us about these benefits, talk to us about what you're doing in resilience today. We have people here from our global partner organization. So there's somebody from your region here focused on resilience who wants to help you work through how to incorporate and address customer needs for resilience. You'll find us in booth 314 on the expo floor in the AWS Village. And if you don't get a chance to come talk to us, please follow up with us at apn-resilience-team@amazon.com. Just with that, thank you so much for joining today. I hope you have a great few days ahead of you, and look forward to seeing you at the booth. Thank you very, very much. And just one reminder, please fill out the sessions survey that's in the application. Thank you.